So I don't know. Is it on? Okay. Mm, how do I see it? Hmm. Are people actually there? Okay. Anyways, let's share my screen. Okay. Is anyone there in the stream? I can see 8 people. Uh, okay, I think there's some settings that I enabled. Okay. Screen. Screen. Share window. Okay, so here it says. So I can see 3 people in the stream. There are 3 people who have joined. Okay, so we will be doing this solo academy get started with Istio. I hope the audio is working correctly. I can see the bar moving. Okay. Okay. Oh, where's my camera? Yep. All right. Yeah. So Istio basically is a service mesh, and this will just take us to the primer of Istio and what it does and why it does it. So, so what is microservices? So let's start here. Okay. So architecture. So all in all, basically there were monoliths first, where you had applications that were like huge pieces of code, and then we started breaking them down. So that's how the microservice pattern came out. Right? So you have applications that can be written with different like you could write it in Python, you could write it in JavaScript, anything, and it would still work, and you could have them communicate between each other. So yeah, so it's basically one thing goes down or so, like one part of the service or one part of the app, you could still, the app would still be usable basically. So then we have, yeah, this is basically this. And yeah, so this just explains what I was just talking about. And so all in all, microservice pattern allows you to deploy faster, You don't have to wait for the slowest issue to be solved or something like that. And you have loosely coupled code. So if anyone wants to if anyone wants to do this course, it is I'm putting this link in the chat. All right. Yeah. So this is the next thing. So benefits of the microservice architecture. You have agility and speed in delivering innovation. You can do CI/CD, increased flexibility, enhanced application. Yes, it's all the good stuff. Microservices and containers. So yeah, so first microservices are probably VMs, like tiny VMs, but now you have things like containers that are even more faster than VMs and provide isolation. So probably people used to run it on Docker or Podman or something like that when it came out. And then they moved on to things like Kubernetes. Kubernetes is a very good thing. Like it's an orchestrator, so basically it takes care of scaling, scaling, and then if you have things like multi-node or multi-region, you can deploy the app on each node in something like a daemon set or something like that. So things like that. It's a good tool. It helps with a lot of things like scaling. The multi-cluster things are also there. The technology basically. But yeah, that's about it. So yeah, this also allows you to move from basically from your VMs to containers, and that's what the microservice architecture supports very easily. If I had to say, because Kubernetes is like a big orchestrator, it gives you all the things you want. There's also things like Nomad, that's from HashiCorp. That's also an orchestrator. That's not as I think feature rich, but it's a very good orchestrator from what I heard. If you want just simple orchestration things, Nomad is also a good alternative. Uh, so yeah, so in the microservice architecture pattern, networking is one of the most I would say important things. For example, if I am unable to reach one network or one container, for example, and what happens if you know uh, there is heavy load and something failed, but I'm still sending like request or something like that to an app that is not working. So there is something called as outlier detection also that can help such cases. So there are a lot of things like MTLS also, which if you had to do, so all these have to be put inside your microservice. And in a way, the whole point of microservices is just to keep it small. Like you just have to have, it should just do one thing in a way. But if you go to see, people just keep putting a lot of things inside it, like retry mechanisms, uh, things like rate limiting and all this. So service mesh helps there also. So yeah, you can read this block of text on the screen. uh, Challenges of microservices and Kubernetes. Okay. So you see, you only should have business logic or application, but you also have all these other things within the microservices. So that's also not good. So yeah, the initial solution is to have a sidecar basically. So your application would be there, and you just have a like a proxy. Like for example, Istio is the Envoy proxy. So you do that, and you have your application. So this the proxy has all the features like that it can implement. It's not necessary that it has to have all the features, but it can extend its capabilities with extensions and things as such. It all depends on the proxy software. So for this purpose, Envoy was used, and it was created by Lyft, I think, if I'm not mistaken. So it provides all this, and you keep your application business logic all separate. So your app just does what the app has to do. Yeah, see, originally built by Lyft. The layer 7 proxy. It can also do L4 stuff, but it's mostly a layer 7 proxy. Uh, yeah, it's like a data plane, like your proxies are a data plane. So HTO is a control plane to control all the, I'd say, change all these proxies that you have, right? Envoy proxy. So HTO is the control plane that controls all these proxies, and you can do things like all these load balancing, encryption, metrics, and all that. Okay, so finally, HTO service mesh. Service mesh is a communication layer in microservices architecture. All the requests to and from each service will travel to the mesh. So the service mesh basically injects like a sidecar proxy, and that sidecar will then communicate with other proxies basically or applications, but it directly won't come from your container, the main application. So you have one more layer of security front of your application. So yeah, in this one, it's just describing what HTO can do into identity-based authentication and authorization, encryption using MTLS, traffic management, like rate limits, quotas, failover, observability, and all these things. Oh, okay. So now we'll see how HTO service mesh works. You can use it's basically to give an overview. There is a HTO proxy that runs, and there is also something like a so each application gets a Envoy sidecar, and HTO has its own. I think it's called HTOD. HTOD is a container that runs, and that is what manages everything. Okay, so yeah, so this is how it works with the proxy. You have a pod, and inside the pod there will be two apps. You can encrypt between pods. So MTLS you can do with pod to pod secure connections, and verify identities and enforce policies. What port, which HTTP verb, and what route. Okay, retry on failure. So this is also a very good thing. You can basically retry, and you can just sort of say, okay, I want to retry on 500x, or I want to retry only on 400x errors. So you can do that also. Plus, you can also route to different versions, depends on the headers and all that. Also, metrics. HTO has a lot of good metrics that you can just pipe it to your observability platform like Prometheus or something, and it's all CRDs. So, you can just use Helm or something like that and do templating and put it in your GitOps pipeline and it will just work. So usually you don't have to do a separate type of deployment strategy and all for all these things. It's just a normal Kubernetes way of declarative control. Add event to the service mesh management plane. So Istio basically is mostly I think a single cluster, but not multi-cluster, multi-cloud. So that is where I think we have Blue Mesh that provides a management plane. Uh, so we also have Istio lifecycle management. We have service meshes and ensuring policies are implemented, global routing, failover. Okay, these are all good things. Okay, so I'm going to skip the quiz and go to the hands-on lab because I want to do the hands-on lab. Okay, so this is started. So this will take some time. Almost there. Okay, this is done. Let's start. All right. Oh, let's, all right. Let's do this one. I hope it's not too small. So I don't think so I require camera on. Okay, so we will be using Istio CTL to first install Istio. So let's just copy this. So we're using Istio 1.16 and we will just we'll just put this into the path. Okay, check the Istio city. Okay, check the Istio CTL version. And then if we want to do something like a check before we install it, so there is already a Kubernetes cluster running inside this environment, and to just do a check, so if we do PSAUX, K3s, uh, K3s. So HTO comes with a lot of profiles. Okay. There is the new profile that is ambient, that is sidecar-less proxy, and we will be using the demo. So just come with a demo profile also. And we will just use HTOCTL to install it. Okay, so we install HTOCTL. Now we'll just check all the resources. Alright, cool. So we have all the resources. We are all running. So you have a HTOD service. You have an HTO egress gateway, ingress gateway. So ingress is for all the incoming connections. Egress is for all the outgoing connections. And alright, so let's do verify install. Yes. So we have verify install all done. Okay, so what's next is we are going to install the Istio telemetry add-ons. So they are going to install Grafana, Jaeger, what is Kiali, and anything else. I think these three for just showing, visualizing how these things run basically. So let's try Prometheus. Right, and you should see it load here. If it load here, we just have to refresh. Yes. So we have the Prometheus UI is working. Now we'll test the Grafana. Same thing, refresh. And we have Grafana also running. And if we put Jaeger, there is Jaeger also. So this Jaeger shows tracing. And lastly, we have Kiali. So Kiali, let's see a second. Kiali is for it shows you uh, visual representation of the traffic within your cluster. If you go to this thing called graph, select namespace Istio system. Uh, right, you can see these idle nodes. So we're going to show, yeah, see, you can see all these idle nodes currently. There is no traffic running in the cluster, so nothing is being shown, but we will see that later. Right, so this does the first lab. Okay, so we have done the first lab. I'm not going to do all, I guess. I'm just going to do one or two. Right, so let's first. So we will be deploying a sample application called Web-API service to the HTTP Ingress Gateway and configure secure access to the service. So Ingress Gateway is where all the ingress traffic comes in. You should use gateway specifically if you want request transaction. So yeah, so currently you can just do basic stuff with this Ingress Gateway, I guess. So let's see what you can do. First, we'll go in the right directory, create the PCPL namespace, Istio in action. Then we will just apply these sample apps. Right. See, if you notice, there is one which has version 1 and the one just normal. You should check all these pods are running or no. Yeah, they're running. So now let's configure the inbound traffic. So for now we have Istio Ingress Gateway will create Kubernetes service for load balancer. Uses gateway IP address to reach the gateway. These are all the services, and if you notice, the ingress gateway is a load balancer, the egress gateway is just a cluster IP. So this is exposed, outside your like at the start of your cluster. If you say ingress sort of, and all the ports are exposed here, and you will just copy this and export the gateway IP and the port and the secure ingress port. It is 443 and 80. And so this is how it looks. Okay, so you have the ingress gateway, you have this namespace HTO in action, and the ingress gateway is in the HTO hyphen system namespace, whereas your applications are in the HTO in action namespace. So the CRTs that are required is gateway for ingress and virtual service. So there is something called as a gateway that you will create, and there is something called as a virtual service that you will define. So you have to create two resources, basically two custom resources. Even if though you have apps, you can still do this. You can configure what code should be exported. Okay, so using the virtual service, you can configure how to route traffic from the Istio ingress gateway to your web-API service. So right now we are not doing anything regarding the mesh. Okay, this is just a normal gateway sort of thing. Uh, let's try it out. Okay. First, you will just see what is there inside these files. I don't know if I should increase this. I'm not sure if it's visible. So yeah, so basically you have this thing called as gateway, right? And you have defined web API gateway as a name. There is a selector called Istio ingress gateway. Right? You have specified the port number, the name, and the protocol. And there is no host currently here. Is that the full file? No, yeah. So yeah, host is defined here as Istio in action.io. So if I'm guessing this correctly, it's going to listen for this particular host name. So if this host matches, then you will then it will do something. So let's see what it does. So we have to create a virtual service. We've named it web-api-gws gateways. It's also got the same host here, Istio and action.io. And if you notice here, we have this gateways option here, and we are sort of matching it with this. And okay, apart from that, we have the route destination that goes to this web-API service that we have, port number 8080. Oh, that's good. So simple, right? So the traffic will come to this gateway, and from this gateway, it will go to web API. So here we have defined a gateway resource and a virtual service resource, and both are in the Istio in action. Both should be in the. Okay, so yeah, we are defining this in the Istio in action namespace. Okay. So let's try it out. So we created the gateway, we created the uh, virtual service. Okay, and it says it will create new routes in the proxy that you should be able to call from outside of the Kubernetes section. So Istio comes with a good command line tool, right? And there is something called a Istio CTL PC or something like that, proxy config, and you can get the routes from here. Um, Refresh it and we get SUC. So we have Istio ingress gateway, Istio ingress gateway. This is the ingress gateway. Okay. So let me see. So because I have to mostly do troubleshooting and just trying out some commands. Istio proxy config. Let's just put proxy config. Proxy config. Right. For some reason I can't access clipboard. Okay, here it is. It's proxy config, cluster listener route pod name dot namespace. So I can't get it by the service in it. Let's try anyways. Okay, I have to specify what command. Proxy route. System. So I have to just quickly look for the Istio system. Where is the port? This one. Okay. So let's try again. Yeah. Okay. So yeah. So here I can see that for it's something called HTTP 8080. The domain name is the Istio and action.io. It matches any prefix, like anything slash API slash get, anything it will match, and it will send it to this virtual service. So in case I were to get an error on the gateway, I would first have to check the route configuration. So I would know that, can the gateway know, does the gateway know where to route, right? So let's continue. Mm, okay. So now we have HTML in action. Let's call this. We get an output. Uh, so we get an output, like a huge output this long, and it says, okay, so this is the web API service that we hit. We have the IP address of the service, start time, end time, duration, body. So hello from web API. Now the web API also has a feature where it can. This is the application. Okay, this is not HTML. This is the application, and it will call other services. So if you notice that we are now hitting the recommendation service, we are hitting the purchase history service, right? So this is a typical microservice pattern, right, where you have multiple smaller services that call other services, right? So that's the crux of the whole say, service, the microservice architecture, right? So we do, okay. Yeah, so actually they already had this thing here, and I can do it with deployment also. Okay, this is new. So I can do it with deploy, and it will just pick it up. Okay, so we've seen how that works. Now we have another diagram for securing the Istio Ingress Gateway with TLS. So this is the Ingress Gateway. So we will secure it using the certificate that updates, and we need to configure the Istio Ingress Gateway to use it. So we'll create a TLS secret. kubectl create. Okay. We created a HTOCT system secret, TLS type, HTN action cert. The key is here and the cert is present here. Alright, that's good. Update the Istio and just gateway to use this cert. Okay. So now we will try to load the certificate in the gateway, right? And we will put it saying TLS mode simple credential name. All right. So Istio supports multiple TLS modes, right? It's got a lot of TLS. I think it's got 3 modes. Let's see if we can find out about it. It will explain gateway. Is that the right way to ask it? It's spec dot servers dot TLS dot node. Oh, okay. So they haven't specified the modes here. They should have, right? See, I think there are 2 modes. One is simple and one is mutual from here, right? We saw the simple mode above. So currently it's in a simple mode. I think that's just one way TLS. Uh, okay, so there is one node that we are pointing to the Istio in action cert, and the cert must be in the same namespace as the ingress gateway development. Even though the gateway resource is an Istio action, the cert must be where the gateway is actually deployed. So the certificate that we created, that has to be in Istio-system only, right? Because ingress gateway is deployed in that namespace. Then we will do what is we will change the we are also going to change the virtual service. Let us just see what we did with the virtual service. Okay, so no, this is just applying the gateway that we did. Okay. I got an error. Weird. Did I create the secret? Yeah, it's already exists. Okay, let's try it again. Oh, it's working now. What happened? Error from server, internal error, validation webhook failed. So end of file. So there probably was a temporary glitch. This is where all the magic happens. But I currently don't know what I should be looking for. Was there like an error here or something like that? So that error seems to be on the validation webhook. So I don't know if it actually reads the HTOD. It's more likely something. Yeah, so I don't see anything here, so it's probably somewhere else. But I'm not going to go down that rabbit hole again. So let's curl. Let's do a curl on the. So this is now an HTTPS connection. Right? This is an HTTPS. Okay, if you follow on port 80 not work. So we have completely disabled activity. It, it's only 443, so there is no 80 port, and it will not work also. No, no connection on 80 because it's not listening on 80 anymore. All right, so we can now visualize. Click on the Grafana UI tile. Should start seeing some metrics. Okay, let's go over. See some metrics we have got. Oh, the success rate is it's 100%. Let's try again. So just to why is this giving me bad reflection? This is the right command. Okay, so I see the error. It says no such file or directory. That is oh, because there is already a double port here. So I have to push to a single port. Now what happened? Now it says why doesn't it take the environment variables? Yes. So bash knows what to do with it. Maybe that's causing an issue. Let's, okay. Anywhere else I have to put nope. Why is it directory but so then I'm confused. Shouldn't be directory. CSR is my syntax wrong? the syntax of oh, this works. What does this say? Okay, instead of call, I'm just this works. Let's try to echo the entire string. This should work. This probably not sure why it's yeah, it works. More stuff. Okay. All right. So we will move ahead. Mesh metrics. Grafana UI. Uh, Mesh metrics appear in global requests to orient to virtual services successfully at gateways are to all right. Let's do a check. Then we should go on the next lab. And so we have so I'm going to just do till adding services to the mesh. Yes, that's okay. It's not too late. We can do another round. So, okay, so let's do the lab. So it's almost an hour. It's a good thing. I started for an hour. All right. So in this lab, we will incrementally add services to the mesh. So now we start with the original service mesh stuff where we can add services to the mesh, add a sidecar to the application, etc. So we are moving on from just a simple gateway deployment. Now what we will do is we will do sidecar injection. Okay, so we have two options: automatic and manual sidecar injection. To enable the automatic sidecar injection, you can use the command below. We will do this. We just add a label the namespace, validate it, let's validate it. Yes, we can see Istio injection enabled. Uh, Okay. Since you added the Istio injection label to the Istio thing, animation controller automatically injects the envoy proxy sidecar during the initial deployment or the restart of port. So there are some constraints, okay, that you need to be aware of. Each service port name must start with a protocol name. The pods must be associated with a Kubernetes service. The pods must not run as a user with UID 1337. The app and version labels are added to provide right, to provide contextual information for metrics and tracing. So if you don't have NetAdmin security rights, you can use the Istio CNI plugin. Using the web API service as an example, you can review its service and deployment descriptor. Okay. Oh, this is a lot. So we created a service account, web API. We created a service. We named it web API. We have given the ports here, that is HTTP protocol TCP port 8080, target port is 8081. Okay. Deployment is created here. Replicas are one, selector, match labels, app to web API, version v1. Okay, what is this? Each service port name must start with the protocol. Okay, so you have to have the protocol name as a port name here. For template, you have metadata labels, app, web API, version v1, annotation. Spec is you can give a service account name here, you can give containers. So this is the usual Kubernetes stuff that I am not going to go. Okay, that's good. This is good. Check the purchase, should validate your own meet the above requirements. Adding services to the mesh. Okay, so to add service to mesh, we can add a sidecar. All right. So now that we have injected, I mean, we have labeled the namespace. Right? We labeled this. So any application, if I restart here, it should get a it should get it should get a sidecar in it. Right? Okay, so currently there is nothing in this namespace. Okay. I think it's HTML application. Right. So we have the pods and they are all one out of one. Right. Now what we will do is we will do kubectl rollout restart. So once we do this, it will restart the web API app. Even this, yeah. So you will see we have added. It's now two pods. So one is the app, one is the sidecar. The app looks good. And we are also able to connect to it as usual using secure connection. There are a lot of things that happens when this gets created. So if you look at the pod manifest or YAML, that's it. That's what it's called, right? Manifest. And if you look at it, you see that here, okay, there are a lot of things that get added, but we have something as a init container, right? That runs and it's called Istio IP tables, and it does this. It runs an IP table command that does all this thing, and you can see the description of what all these commands are. It basically redirects all traffic to the sidecar, incoming and outgoing, and also you get a lot of other things like you can there are these ports that are specified, etc. You can actually log into this container to do this, right? You can see all what these ports mean. Like in the envoy port is given. Then we have, if you look here on the side, we have uh, envoy port is 1 15,001. The hyphen Z is your inbound capture port, so port to which all the inbound TCP traffic should be redirected to. You have your hyphen U, that is a proxy UID. So this is a proxy UID 1337. Then you have hyphen M. So M is, I think, what happens when traffic matches. So the interception mode is set to redirect. Then you have hyphen I, that is CIDR. Hyphen X is, what is hyphen X? Hyphen X, I can't see. Yeah, it is. Exclude CIDR is also nothing. And you have hyphen B. What is hyphen B? The Istio inbound ports. So wildcard is, it has all ports redirections. This. And lastly, hyphen D, that is local exclude ports. So comma separated list of inbound ports to be excluded from redirection to envoy. So these ports won't be redirected to the envoy port. So that's good. So we saw that IP tables runs before everything runs, and so then you can see, you can even see this CPM describe. Uh, it's different for, I guess. So scale down replica. Is it pod or is it pods? Yeah. So here you notice that the Istio proxy service was also created as another container, and you have the faker service here. So that's how it does it. There was some readiness probe failures that happened, I guess. Anyways, so moving on, this means service deployment. So yeah, to do this you need uh, net admin and net raw security capabilities within the CNI, right? So we have to also keep in check limits, CPU memory limits. So those ports that we saw before, it's 15021 is for health check, 15090 is for the envoy port to emit its metrics to Prometheus, and port 15020 is for the merge Prometheus metrics collected from the Istio agent, the envoy proxy. And we also have the HTOD CSR token, which is for MTLS. Alright, so we will now add all the remaining services also to the mesh. Okay, so we have added till now we have added, you say, sidecars to the mesh. Sorry, we have added applications to the mesh with sidecars. Uh, okay, you can do distributed tracing. Look at the UI. Okay. Oh, we can see traces. Let's request ID. Okay, so that's it for the stream because I only have this much brain energy study, like just for 1 hour. So that's it. I will try to do this tomorrow again. Tomorrow is Saturday, but let's see. Just okay. And I just have to stop.